Hello everyone. So today we will discuss about what is dimensional formula and what are the dimensional formula of fundamental physical quantities as well as for derived quantities. So let's get into the video. A dimensional formula is a thing in which we can represent all physical quantities as m, l and t with a closed bracket. This is as m, l, t till we are discussing about in case of mechanics. So if we go something like thermodynamics, we will use like k, and in case of electric current we will use like a, and we can see all that cases. So this is the basic form. Now let's discuss about fundamental physical quantities and their dimensional formula. The first fundamental physical quantity we will see is length. Its SI unit is meter, represented in small m, lowercase m, and its dimensional formula is just capital L. This is its dimensional formula. The next physical quantity we will see is mass. Its SI unit is kilogram, simply represented in lowercase kg, and its dimensional formula is capital M. The next physical quantity is time. The SI unit is second, which is capital S, and the dimensional formula of time is capital T. The next physical quantity is temperature. Its SI unit is Kelvin, represented by capital K, and its dimensional formula is capital K, or simply we can say it as theta. The next physical quantity we will see is electric current. The SI unit of electric current is ampere, represented by uppercase A, and its dimensional formula is capital A, or simply I. The next physical quantity we will see is amount of substance. Its SI unit is mole. Its SI unit is mole, and its dimensional formula is also same as, that is mole. The next physical quantity we will see is luminous intensity. Its SI unit is candela, that is C and D. Its dimensional formula is also same as its symbol, that is CD is its dimensional formula. Okay, this is the summary of the fundamental physical quantity, its SI unit, and what its respective dimensional formula. Please make a note of it. Now let's discuss about dimensional formula of derived physical quantities. The first one we're gonna look is area, the dimensional physical quantity. what is area? Usually area is the product of length and breadth. The formula for area is length times breadth. Breadth is also a kind of length, so we can write, so A is equal to L times L, that is A is equal to L square. So this is our dimensional formula for area. If you're gonna represent them in MLT form, you will get m power 0 L square t power 0. Now let's get on to our next derived physical quantity, that is volume. What is the formula for volume? L into B into H. So as we have already L, B is also a kind of length and H is also a kind of length, so it will come as L times L times L. So we can say that it is L cube. This is our dimensional formula for volume. If you're going to represent them in M, L and T form, we would get m power 0 L cube t power 0. Our next derived physical quantity is density. What is the formula for density? It is mass by volume. What is mass dimensional formula? You know, it's capital M. What is the dimensional formula of volume? As we saw before here, L cube. We have the L cube here, so just write L cube here. You know the simple math, that is, if you have a power over here which is positive, if you want to get the whole thing to numerator, what happens? The power will become negative. That's a simple math, right? So we will get m L power minus 3. So this is our dimensional formula for density. If you're gonna write it in M, L and T form, you would get m is also written as m power 1, which is both same, m L power minus 3 t power 0. Our next derived physical quantity is speed. What is the formula of speed? Yeah, you know that. Speed equals distance by time. What is the dimensional formula of distance? Yeah, it's correct. Distance is nothing but length, which is capital L, and time, which is capital T. And you know the simple math that if an power in denominator goes to numerator, the power will automatically become negative. So our dimensional formula for speed is LT power minus 1. So this is our dimensional formula for speed. If you're gonna write them in M, L and T form, you would probably get m power 0 L power 1, which is nothing but L, and T power minus 1. The next derived physical quantity we're gonna see is velocity. What is the formula of velocity? Velocity equals displacement by time. Displacement is nothing but length, which is L, and time is T. So we will get L T power minus 1. So this is our dimensional formula for velocity. And you can observe that both speed and velocity have equal dimensional formula, that is LT power minus 1. And if you're gonna represent them in MLT form, you would probably get same as the speed, that is m power 0 L power 1 or L T power minus 1, the closed brackets. The next derived physical quantity is acceleration. Acceleration is nothing but velocity by time. The dimensional formula of velocity, as we saw earlier, is LT power minus 1 by the dimensional formula of time is T. As a result of simple math, we will get as the T goes upwards, it becomes minus 1. Minus 1 minus 1 is minus 2. So this implies acceleration dimensional formula is L t power minus 2. If you are representing them in m, l and t form, you would probably get m power 0, l power 1, t power minus 2. The next derived physical quantity we will see is acceleration due to gravity. It is usually denoted by meter per second square that we say no, so meter by second square. So for meter we can say as L for second square, which is as a time, so we can say t square. So we can say its dimensional formula as L t power minus 2. If you're gonna representing them in m, l and t form, you would probably get m power 0, l power 1, t power minus 2. Next derived physical quantity is force. What is the formula of force? Yes, by Newton's second law, you would all came across to know that formula as force is equal to mass times acceleration. So the dimension of mass is same as the m, capital M, and acceleration is lt power minus 2. If we would combine this, we will get m, l, t power minus 2. How this is happening means, here there is no m, so it is considered as m power 0. Here it is, there is 1, there is a m power 1, so 1 plus 0 is same as 1, so we get m power 1 is same as m, and this l will come as of that, come same as that, and t power minus 2 also come same as that. So m, l, t power minus 2 is the dimensional formula of force. The next derived physical quantity we are seeing is pressure. The formula of pressure is force by area. What is the dimensional formula of force? As we saw earlier, ml t power minus 2. What is the dimensional formula of area? L square. So let's write that. So m l t power minus 2 by L square. As the L square comes numerator, it will act as minus 2. So you have 1. 1 minus 2 is minus 1. As of simple math, we will get m l power minus 1 t power minus 2 is a dimensional formula for pressure. Now let's see the next derived physical quantity, that is kinetic energy. The formula of kinetic energy is half mv square. In this case, you should note that this is a constant. So constants are always dimensionless. So these are numbers. So these numbers are constants. So basically constants are dimensionless. With these remaining values, let's get into for substitution. So we write m v square, where m remains as m, where velocity is lt power minus 1 with this whole square. As of simple math, we will get m into l square t power minus 2 with this whole substituting in. So finally we would get m l square t power minus 2. The next derived physical quantity is potential energy. The formula of potential energy is mgh, where m is the mass and g is the acceleration due to gravity and h is the height, so which is also can be represented as length. The dimensional formula for m is m. For acceleration due to gravity, it is lt power minus 2, and for height is a kind of length, so we can represent it just as capital L. So this will become as m comes as m, and we have two L's, so L into L, that is L square, and t power minus 2. So m L square t power minus 2 is the dimensional formula for potential energy. The next derived physical quantity is frequency. The formula for frequency is 1 by time, which is 1 by t. So it can be represented as we have discussed earlier before. If power with positive power, that is if t power 1 is here, so if it go numerator, means the power positive will become negative and the resultant will be t power minus 1. So t power minus 1 is the dimensional formula for frequency. if you're gonna write them in the MLT form, you would get m power 0 L power 0 T power minus 1. The next derived physical quantity we will see is electrical charge. We know the general formula I equals Q by T. I equals Q by T. So for finding Q, we can say I times T. So electrical charge is equal to I times T. I is nothing but ampere, as we first itself already saw that fundamental physical quantities are dimensional. For I, the current we have A. We can present also in I, but we would usually represent in A. A and T is nothing but time, just T. So we can say electrical charge AT. This is nothing but just AT. If you're gonna represent them in like MLT form, you would probably get m power 0 L power 0 T power 1 A power 1. Our next derived physical quantity is work. The formula for work is force into displacement. So for the force, dimensional formula is ml T power minus 2. For displacement, it's simply capital L. So finally it will be m L square T power minus 2. So this is our dimensional formula for work. Our next derived physical quantity is power. The formula for power is work by time. The dimensional formula for work is ml square T power minus 2. ml square T power minus 2. In denominator it's time, so capital T. So finally, if this is plus 1, if it go denominator, it will become minus 1. So minus 2 minus 1 is minus 3. So our final dimensional formula for power is m L square T power minus 3. Right? Okay. The next derived physical quantity we will say is electric potential. The formula for electric potential is V is equal to W by Q. So we'll write as W by Q. W is work done, where Q is the charge. The formula for work done is m L square T power minus 2. For charge it is A T. So if this T go to this is T power 1, if this go to numerator means it will become T power minus 1. So minus 2 minus 1 is T power minus 3, and this is A power 1. So if it go up it go numerator means it is A power minus 1. So m L square T power minus 3 A power minus 1 is the dimensional formula for electric potential. The next derived physical quantity is electrical resistance. This formula for electrical resistance can be obtained in a famous equation that you know already, that is Ohm's law. What is it? Says V equals I times R. Then what will be the R? Yes, so R gonna be V by I. So this is the formula for electrical resistance. Here V is nothing but electrical potential. What is the dimensional formula for electrical potential? M L square T power minus 3, then A power minus 1. Below it has I is nothing but A. So if we bring this is in the denominator as A power 1, If we bring it to the numerator, it will become minus 1. So minus 1 is minus 2. So the dimensional formula for electrical resistance gonna be m L square T power minus 3 and A power minus 2. The next derived physical quantity is velocity gradient. You don't worry about the gradient. Gradient means dividing it by length. So we can say that velocity by length. So velocity by length. Velocity by length. So dimensional formula for velocity is LT power minus 1 and length is L. So this L can be cancelled as a basic math. So your resultant value will be T power minus 1. So this is your dimensional formula for velocity gradient. The next derived physical quantity is temperature gradient. What is meant by gradient? We saw already. A gradient means what is there, we will divide it by length. So what is here? Temperature. That is temperature by length. Temperature is K and length is L. So finally we can say that K L power minus 1. So this is your dimension formula for temperature gradient. This is K L power minus 1. If you're gonna say them in the MLT form, you would get M power 0, L power minus 1, T power 0, K power 1. The next one is pressure gradient. So that is pressure divided by gradient is nothing but length. The dimensional formula for pressure is, so we can write m L square T power minus 2 divided by L. This is L is an L power 1. If it goes numerator means it will become L power minus 1. L power 2, that is 2 minus 1 is 1. So we can write m L T power minus 2 as the dimension formula for pressure gradient. The last derived physical quantity is energy. Heat is a kind of energy, so I have written here. So I hope that you know the basic formula I square or T, which you have learned in schools. That is the formula for heat also, because it is a kind of energy. It is written here. I is electric current, which is ampere. So we can write ampere square. So the dimensional formula for resistance is ml square T power minus 3 A square, and this is nothing but time, which is as that is T. Here you can cancel out this A square and this A square. So what will be the resultant? The resultant will be m L square T power minus 3. This is T1, so minus 3 plus 1 is minus 2. So this is nothing but m L square T power minus 2 is the dimensional formula for energy or heat. Now let's look at a quick summary what we have done. Dimensional formula of area is m power 0 L square T power 0. Dimensional formula of volume is m power 0 L cube T power 0. The dimensional formula for density is m power 1 L power minus 3 T power 0. and which is also can be represented as ml minus 3. And next is speed. Speed dimensional formula is m power 0 l power 1 t power minus 1, which is represented as lt power minus 1. The next one is velocity. So its dimensional formula is m power 0 l power 1 t power minus 1, which is also represented as lt power minus 1. Here dimension formula for speed and velocity are same. That's the thing that you should remember. The next one is acceleration. The dimensional formula for acceleration is m power 0 l power 1 t power minus 2, which is also can be represented as lt power minus 2. The next one is acceleration due to gravity g. That is m power 0 l power 1 t power minus 2, which is also represented as lt power minus 2. Here you should note that acceleration and acceleration due to gravity, both dimension formulas are same. That's the thing that you should remember. The next one is force. Its dimension formula is mlt power minus 2. The next one is pressure. Its dimension formula is ml power minus 1 t power minus 2. Next one is kinetic energy. Its dimensional formula is ml square t power minus 2. And next one is potential energy. Its dimensional formula is also ml square t power minus 2. Here you should note that the dimensional formulas of kinetic energy and potential energy are same. Here this is the thing that you should keep in the mind. The next one is frequency. M power 0 l power 0 t power minus 1, which is represented as t power minus 1. The next one is electrical charge. It is represented as m power 0 l power 0 t power 1 a power 1. It is shortly represented as at. And the next one is work. Work dimensional formula is ml square t power minus 2. Dimensional formula for power is ml square t power minus 3. The dimension formula for electric potential is ml square t power minus 3 a power minus 1. And the dimensional formula for electrical resistance is ml square t power minus 3 a power minus 2. The dimensional formula for velocity gradient is t power minus 1. In short, you can say that m power 0 l power 0 t power minus 1. And remember that gradient is nothing but length. It's nothing but length. That's the thing that you should remember right over here. And the temperature gradient is m power 0 l power minus 1 t power 0 k power 1, which is can be shortly represented as k l power minus 1. And dimensional formula for pressure gradient is ml t power minus 2. And the dimension formula for heat or energy is nothing but ml square t power minus 2. The conclusion is that if you know all formulas and if you find some of the dimensional formulas, you can substitute in various formulas and you can get all of the dimensional formulas present. And I hope that you enjoyed this session. Thank you for watching and have a good day.